MVP, is the tooling from Microsoft for developing Windows applications is pretty efficient. There's quite a few features like now they call that XAML hot reload, C# edit and continue. The deployment time is fairly low. If you've been doing Xamarin iOS or Android, deploying on a device can take quite some time. So that's what it's all about. When you're building your application, it's just about using all the tooling Microsoft provide. And one thing that we've been using it for is the debugger. The debugger for that comes with a UWP application that allows you to do so many things that the Mono debugger doesn't allow you to do. And if you're an advanced user of that, it's something that's missing very quickly. So here's what we're using, and the reason we've been doing all this with Visual Studio. It's what is called XAML hot reload, and just going to be sizing that like a would. So with my application, I want to be able to just start the application and just develop the application down to the end, and maybe not stop the execution and just go up to the end. So it's not something that Microsoft is improving on that scenario, but you can go pretty far into the development of your application just by starting it and starting to do something with it. So what you can see here is I've just typed something, I didn't save anything, and it updated right away. So I can do things like this, and it just updates. So I didn't save, and that's the very important part of that scenario. So that means that if I want to change the margin and put a 500 in there, well, maybe that's too much, but let's say 100, then it's going to change right away for any kind of property. So if I change the color and all that, that's the good thing. Now, one of the very important part of that is that you can do other things like, for instance, adding a stack panel there, and I'm going to be adding a slider. So when I do that, my slider just happens to appear right away, and I can interact with it. It's the live application that's the interesting part. So now if I name my slider, and that I use that slider using data binding. So let's say I do this, and I say that the value property of my slider, which is the current position of the slider, and that I select that and I say that it's the text of the text block. Now my text block now contains the position of the slider, and it just updates right away. So this feature, if you've been doing data binding using XAML or data binding in general, and in MVVM patterns, so it's all about knowing your properties and all that, and debugging bindings can be complicated. And if you have to stop your application and restart every time, that's extremely time consuming. So you don't want to do that. And that's what that feature is all about. It's all about modifying content and just adding features without restarting the application. So now that I've shown you this, there's a few things that you can do as well, like C# edit and continue, but I won't go in that direction for now. It's all about modifying your C# code and just adding features on top of that. So now what I can do is just go over to my WebAssembly project and start it. So what it's going to do, it's going to create a small website that contains my C# code and a few set of other WebAssembly files, the DLL files, and some other resources. And it's going to start the browser of my choice. So at this point, I think it's going to be either Chrome or Edge Dev, or which one that was selected at the point. So it's basically the experience of developing a website, but it's an app. So it's where it gets a bit different. So now I've started my application, and in the browser, I have the exact same thing. And I can change that, and it updates right away. So I've taken my Windows application and ported it over to the web without changing anything. So other thing that is interesting is that we've been working on a feature that does pretty much the same thing that Windows has been doing with the XAML hot reload. So if the demo works properly, and we're still working on that one, but it's another interesting part, I could probably just duplicate that and have too much margin, so I'm going to be removing that margin. And save again. And now I'm going to be having hot reload inside of the browser for the XAML as well. So that loop is all about making sure that your productivity goes up and that you're not waiting for your tooling to just build your application and just spend your time looking at the machine doing something that's not useful. So it's pretty much the same thing running for iOS and Android. If you have an emulator running on that machine, so the machine's pretty new. It's a laptop, so if you're running too many VMs on it, it's going to slow down too much. So I'm not going to be showing you Android for now, and you're going to see the reason why after that. But if you're developing for iOS, are there people using Xamarin iOS? Okay, so you know what I mean by it takes time to build. So it can take quite a bit of time to deploy an application to a simulator, and even worse when deploying to a device. So that's the kind of loop that makes it interesting. So you deploy once to your device, and then you can alter the content there. So another thing that is interesting is that, so I've shown you kind of a binding like this, but I can put something else that's a bit more, let's say, more complex, or like the navigation view control. So that's a control that is about navigation from one page to another. So basically you have a pane on this side that will give you some items, like in the calculator, for instance. The Windows calculator has the same thing. So you have a pane that gives you a section to navigate to, and you have a main section that shows the content that you want to show. And well, in that context, there's nothing that I put there, but I could put something in the content and then navigate from one side to the other. So that gives you an idea of the development flow that you can have with an application like that. And you can go pretty far when you want to develop that application using XAML hot reload. So in terms of supporting XAML content and XAML features, we're doing control templating, data templating, sliding theming. We're supporting dark theme and white themes and light themes that is available from the system. Inside of a browser, the latest versions of browsers support the detection of the ambient theming. So if you're in dark theme, then you're going to get that into the application running as well. There's notion of conditional XAML, the question that you asked before. So the point is, if I'm on iOS and I want to have a very specific color or a very specific control shown at that time, I can have conditional XAML specified at that time. There's also native controls integration. So that's the interesting part with Uno. You can style a control to use the native control or the XAML control. So when you create a button, it may look like a button on Windows, but it should be able to look like an Android button on Android. So there's a way for you to choose between the native style or the common style that is looking the same on all platforms. So that's what we call a native control integration. We have animation support for visual states and state triggers. State triggers is one feature that allows to, let's say, if you're in a window, when it goes over a certain size, then you can change your UI to look differently. That's pretty much what the calculator does here. If you're changing the size, you see that there's a section on the side that just happens to be there because there's more real estate. That's what state triggers allows you to do. There's also lots of data binding features that I've shown you with the sliders. Complex text blocks is also something that's very important when you want to display, let's say, very long string of text that's data bound in some places. Like I want to have the beginning in blue, then a number that's data bound, and then some text that is in bold, and then the rest that's in dark. That's something that's possible to do. So it allows to have very rich and visually rich applications. Shapes and brushes is also very important if you want to draw some custom component. Let's say you're making I don't know, some kind of a chart, or you want to have a gouge. Maybe I'm not saying it right. Gouge. Okay. And you want to display something like that. Then you want to draw something. That's the kind of thing that is possible to do. Localization is also very important. and it's something that you can do and place the assets in the same folder. So you place that in the shared project of the application, and Uno is going to be taking care of taking all your resources and port them over to the other platforms without you doing anything. And that's if you've done some Xamarin development, you probably understand why that is a problem, because the file formats are different. So we're taking care of that. Scaling of assets also is managed automatically. So if you're putting assets using the UWP file format, they're automatically pushed over to iOS and Android and the web using the same using the native naming, but you don't need to worry about that. As I mentioned at the beginning, the Inventive, so the company that's behind Uno, has been developing applications for a very long time. And we've been doing applications such as a movie theaters company in Canada, it's called Cineplex. An application that does with the it's a veterinarian company. It's VCA hospitals, I think. And other, there's a one for, and that one's interesting. It's about getting kids to understand how to play hockey. So that's pretty interesting application. So that's kind of a type of application that are possible to do with Uno, and they're available on the stores for most of those. So you can go and try. Were
those applications built with Uno?
Yes, they were built. They were all built with Uno from the ground up.
Can we do the macOS application?
So macOS is not supported yet, and we're looking for contributors to do it. So because there's demand, but not enough. So we're in the process of determining how we will be doing this. So when we're talking about adding more platforms, and Linux is also in great demand, where we basically want to put the pieces in place for the community to contribute and provide the support for it. At this point, it's a bit more difficult, so we need to restructure a little bit of the source. But it's going to be one of our next stops to provide to allow for the community to help us do great things.
Okay. And another question.
Yes.
So right now, like all the cross-platform thing. So whenever we are creating a new element or something, we need to write like custom renderer for like all the platforms.
Yes.
Right. So is the same problem in Uno also?
It depends.
Okay.
So it depends on the type of control. So let's say if you want to make an image button, for instance, there's no need for specific controls to do that, because you can basically have the same rendering on all platforms. So you use borders and texts and shapes and all that to basically draw your control by yourself, and that is cross-platform. So you don't need to do anything specific to have that across all those platforms, and even newer ones. So let's say if we start adding Linux and macOS support, your control is going to be working on those platforms as well. Now there's another set of controls or types of controls that may be a bit more complex. So let's say, for instance, you want a signature pad. And there it's very specific signature pad because it has a very deep integration with the system that we don't support. So what you can do is basically create a what we call a custom control, and using conditional XAML, basically place the control that you need. You place the 3 controls or the n controls that you need for each platform inside of that custom control, and then instantiate that control inside of whatever part of the application that you need. So there's no notion of render. You don't need to tie a control or let's say a generic control to its platform counterpart. You can just take that counterpart and just place it into the control directly. There's no need to jump through hoops to get there.
Okay.
So in terms of supported libraries, we support Prism, reactive extensions. So that's a very large one, even on WebAssembly. So that is one of the things that was very interesting. When we got that to work on WebAssembly, we got amazed, because it's such a very complex piece of code that's done by very brilliant people at Microsoft, and it works pretty well. Single-threaded for now because of JavaScript, but that's gonna change pretty soon. Windows Community Toolkit, which is a set of very nice controls that have been made by primarily Microsoft, but other other very important contributors. We're talking about controls such as swipe panels and tap controls and things like that that are provided from that control. Reactive UI as well. Are they users of Reactive UI? Interesting. Okay, so I encourage you to look at that one. It's all about reactive programming and reactive extensions. It's a different paradigm into development, and it can you have to wrap your head around it, but it's very interesting. It's pretty close to what people that are doing React development are using through all the variation of the reactive extensions implementation on the other platforms and languages. But it's a very, very interesting framework. And there's also the very interesting framework MVVM toolkit. It's a light one. It's all about creating MVVM in a very small way. The library is maintained by Laurent Bugnot from Microsoft. Well, now Microsoft, but at the time it wasn't. So all those are supported by Uno. You can just take the packages and integrate them into an Uno application and it will just work. So WinUI 3. Microsoft announced something that is very interesting and very important for us at the Uno platform. So WinUI is basically what Microsoft has been doing to pull out the XAML and let's say the XAML support for Windows 10 inside of NuGet packages that you can install. The biggest problem that they had is that they developed WinUI as part of the system. So that means that if you wanted to use newer features of WinUI, you had to update your operating system to newer versions to benefit from that, and that causes lots of troubles. Either for them because they had to have quirks mode to be able to support all those versions of applications that were expecting something and couldn't change it, but also for developers of applications, they want to use the latest and greatest, but their user are in 3 or 4 versions back, so they have to wait for a long time to be enabling their application to use the latest features. So basically what they did is just pull everything out and open source it in the process. So for now they're at the pulled out. They released a NuGet package that contains all of the WinUI 3 code, and they're going to be open sourcing that up probably around next year. I think it's probably around next year.
It's right before build, I thought that's what they said.
It said February.
Yeah, around next year. So February next year or something. So
you mean it'll be ready to
it'll
use
be ready for
production ready?
production ready at build, but open sourcing it for development around February.
Okay.
So we've been working with them for a while, and we've been having access to that source code ahead of time, and we've been starting incorporating pieces of the private sources inside of Uno. So whether it be behaviors, specific values, corner cases, unit tests. We've been integrating unit tests from the Microsoft source code inside of Uno so that we can make sure that the behavior that we're having is the proper one. And we found that in some cases it's not. So because we basically reverse engineered what they've been doing for all those years in closed source. So it means that we're going to be pulling those sources and integrating that into Uno so that the behavior is exactly the same between what Windows provides and or the WinUI packages provide and what Uno provides on the other platforms. They've changed a few things like namespaces and all that, but I won't get into those details. It's not very useful. And testing is very important for us. And it's high value. It's even more higher value than the actual code itself because it's all about the edge cases. And they can, oh yeah, they can kill. So now, if we go back a little bit more into native development versus web development, and it's been a battle. Up to this point, it's mostly JavaScript, and it's for most people it's still JavaScript for the web. You can do derivatives of JavaScript, you can do TypeScript or Dart or things like that, but it still is JavaScript underneath. There's no way. There used to be no way around it. So you had to choose between a list of, or probably a subset of a very larger list of things like deployment. It's interesting on the web, but on mobile desktop, you have to go through stores. That's not so nice. but latency on mobile and desktop, it's pretty good. When you click, you have the result right away. On the web, not so much. Sometimes there's pretty delay. So you have to choose between all those constraints, and the biggest one is I have to rewrite the JavaScript. If you have an application that's on mobile and on mobile or on desktop, if you want to go to the web, no other way around. And that's where WebAssembly came in. So what is WebAssembly? WebAssembly, it's a bytecode that's been designed for the web, but there's a few things around that one. But it's basically for the web. There's a binary format, so basically download a .wasm file. It has a textual representation that looks like this. It's not pretty. It's not meant to be read that much. It's kind of like if you've done x86 assembler, that's what it looks like pretty much. It's not very useful. The interesting part is that it's very simple in terms of what it provides in terms of features. It only supports 4 types of data in 32 bits, int 64 bits, float 32 bits, floats 64 bits. That's it. There's nothing else. And all the languages that will be targeting that have to do with that. They can't do anything else. It supports security in some cases, and I'm going to be talking about that as well, but that's what it looks like. So you can see it as a compilation target for any language that exists, and there are new languages that are added every day. It's pretty much the list is getting longer every week that passes, but the larger ones are C++, Rust, Go, Java, Python, PHP. They're all running inside of the browser through WebAssembly. And the important part about WebAssembly is that it's not something that you will code in. It's something you will code for. In the same way that if you're targeting an ARM device or x64 or x86 or something like that, you're going to be choosing that target in whatever environment you're going to be working on. It's not something you will be developing for very specifically. It's supported by all major browsers, and it's been for quite a while now. That's a major achievement in terms of web standards. We're talking about something like 3 years of development. It's never happened in any kind of feature that come from any kind of web standard. So that's in itself, it's an achievement. And Edge Dev, now that with the new logo, Safari, the previous Edge, all the mobile browsers, they all support it now in some form or another. So the standard is evolving. There are a few things that are being added to the specification, but it's pretty good. So that means that the behavior that you have on one browser is exactly the same on any other, because the WebAssembly specification is so simple. It's fairly easy for the implementers to get something working, and working the same on all of them. So one key aspect of WebAssembly compared to JavaScript is the notion of the JavaScript file. The biggest problem of the JavaScript file is that you have to get the whole JavaScript file to be able to do something with it. You cannot start to parse a few things in between, because if you have half of the file, well, you don't know if a function is going to be called afterwards. So they can do tricks to do a few things, but that's pretty much what they can do. So they have to wait for the end of the file to be downloaded completely. And sometimes they have to wait for other files to be downloaded as well, because maybe you're referencing something that comes from another file, so it doesn't work as well. So that means that basically when you're looking at the threading aspect of the loading of a JavaScript file, is pretty much the network at the beginning, and then a second thread that does parsing, and then you come back to the same thread and then compile and execute. It's very hard for JavaScript engines to compile on multiple threads. With WebAssembly, they changed that completely. A WebAssembly module is self-contained, and there's a notion of streaming compilation. So bytes come in, and they get compiled as they come in. So you can get a very large module. It doesn't matter. It just compiles as it comes in. So that means that you get as many cores as you have, they're going to be using it to compile the WebAssembly module. And best of all, they can take that module and store it on the disk compiled. So that means that the next time you come to that module, it's already compiled and it can be reused exactly as it's been compiled, which is very difficult to do for JavaScript. So that's one of the key aspects of the performance of WebAssembly. Security is another big one. Because of the aspect of, so I didn't mention WebAssembly, because it's pre-installed in every browser. There's no need to have any kind of add-on. So it's not like Flash or any kind of other plugins like Silverlight or Java applets or things like that. You don't need to install anything. It's just part of the browser. And one of the big reason the plugins were not, were pushed out of the ecosystem is that because they were unsafe. They were executing things underneath that were not, done the right way, and then it was a nightmare for vendors to do something proper with the security that was needed at the time. So they got pushed out, and now we got WebAssembly, and they've taken the security aspects into account. That means that basically a WebAssembly module cannot do anything much that what a JavaScript module is able to do. And it cannot get out of the sandbox. It cannot execute inside of its own bounds. If you allocate something, you cannot go over. You cannot do, if you're into security a little bit, jumping into from one method to another method. You cannot do that kind of things by overflowing the memory. So that's the kind of security features that are very important to avoid all the security messes that have been happening because of the native plugins. So it's all about not repeating the errors of the native plugins that have been provided and developed in the past. That being said, people have been implementing Flash in WebAssembly, so you may still see Flash sites popping up, but this time using WebAssembly instead. Another interesting aspect of WebAssembly is that it's neither web nor assembly, and if you look at the spec for WebAssembly, you will see only the word browser only once. It's not there anymore. It's just mentioned because web, but that's pretty much it. So WebAssembly is just a marketing name. What it really means is that you can take a WebAssembly module and run it outside of the browser. And the now not anymore CEO of Docker said that if WebAssembly were to have been invented when Docker was invented, Docker would not have been invented because of the security features that are embedded into WebAssembly. So that's a pretty major statement. So maybe it's a bit too far in terms of not saying Docker doesn't need to exist, because there's all sorts of notion that has been found out of Docker, but the original concept of Docker was about that, and WebAssembly treats one is able to do all those things. So lots of people have been developing things outside of the browser. Ethereum has been doing very interesting things. So cryptocurrency that uses what they call smart contracts. They're executing code inside of anyone's machine using WebAssembly, but in a secure way. So that's very interesting. There's Wasmer that now has been able to run OpenSSH using WebAssembly. So OpenSSH has been compiled to WebAssembly and run as a command line tool. So it just runs in any platform. People have been compiling an LVM and Clang to WebAssembly to run it inside of the browser, but also on the command line. So there's no dependency to the platform that's underneath. So that's very interesting to see. There Cloudflare also as well. It's interesting. Cloudflare, they're using WebAssembly to execute code at their edge of the network. So as an individual or a company, you can provide code to Cloudflare to execute at their edge of the network, so that you can alter the behavior of their network for your end, but it's your code, and they're trusting it to run on their end, so they're on their edge. So that's pretty major in terms of being able to run code on that. There are other aspects like memory concerns and memory pressure and things like that, or startup time that compared to Node.js, it makes it very interesting. I personally see it as a Node.js killer, because it can replace most of the languages that made Node.js very interesting, and the cross-platform aspect. That's my view. In terms of use cases, AutoCAD has been pushing things to be able to run there. Unity has been doing things as well, so you can have the full Unity runtime running inside of the browser. The Emacs also has been compiled to WebAssembly. A few days ago, Diablo was compiled down to WebAssembly, so it's running in the browser. So if you want to, you can search Diablo and WebAssembly, the original one from the year 2000, that you can use on your browser. So that's an amazing one. But
I wonder if the Visual Studio on the web is a WebAssembly.
no, it's TypeScript. So that's VS Code. That's VS Code. So VS Code is it's TypeScript all the way.
Okay.
But maybe at some point you're going to be using WebAssembly for very key specific features of performance. But there's one that's very interesting. It's Windows 2000. So I'm going to be showing you that one. It's always amazing to see. So if I can select it because of that. There. Oh, it's not started. I'll come back to it because it restarted. So this is Windows 2000 starting in the browser. It's not too bad. It should be starting quickly because the rest isn't there. So there's this guy that specializes in making VMs, and it's been taking his code that creates a VM. It has ported that over to WebAssembly, and is basically taken the whole. It's taken a let's say a VHD in a way, and allows a WebAssembly module to pick that up block by block and download it to the browser. So this is not a remote desktop. This is running inside of the browser, and I'm going to be doing something that's very important for any kind of machine that's been running Windows 2000, and it's the so that one. So it's a bit slow at the beginning. I don't know exactly why. Probably there's a few things that runs at the back, but yeah, it's the Minesweeper. It's the application to run on that kind of machine. So it's the actual Windows 2000 running inside of the browser, and it's kind of mind-blowing. That means that a whole operating system can run there. Oh, there's also Firefox. So Firefox can run WebAssembly. So that means that you could run WebAssembly in WebAssembly. Can go far. So that's the kind of thing that looks very interesting. So it can go quite far, and you know, there's a say that if something that can be compiled down to WebAssembly, it will eventually be compiled to WebAssembly. So it's pretty much everything, pretty much. So that's gonna be very interesting in the future.
It's what the JVM should have been.
It's what the JVM should have been. And the interesting part about that is, and .NET could have been with that as well.
Yeah, it could have.
But the single reason that makes WebAssembly interesting is that there's no vendor behind it.
That's right.
That's
open source.
That's the key that makes it different. And open source, so the specification is open source. There's no implementation. The implementation could be closed source or whatever. They're not in most cases, but the spec's open source and it's not tied to a vendor.
Right.
But you know, JVM was, .NET was, and a few others were, and that because of monopolistic concerns and things like that, they would bite over. So that makes it very interesting. So that's the VM. So in terms of architecture, what it looks like is that you have basically your code on the side at the top. You're basically compiling down to WebAssembly. Then WebAssembly is going inside of the browser. It's going through JavaScript, and JavaScript can go to W3C APIs. So basically manipulate the DOM or anything like let's say Web Bluetooth or WebGL or anything like that. But it can go also to directly to the CPU. So WebAssembly executes directly on the CPU. There's no emulation of any kind. So that's what makes it very interesting in terms of performance, because it's very down to the metal. And there are quite a few features that are being added as we speak in terms of getting use of the CPU. And SIMD extensions, SIMD instructions are one of the key aspects in terms of getting things like audio processing and video processing and anything that does intense computation. AI is getting very interesting in that regard. TensorFlow is getting compiled onto WebAssembly as well,
Really?
so that it gets the use of threading and SIMD extensions. So that is getting added to the browsers over the next few months. So I'm going to be showing you a little bit of WebAssembly directly. It's probably the last time you're going to be seeing this because it's not very useful for the rest. I'm going to be closing the VM because it takes a bit of CPU. So I'm going to be creating a C program. I hope it's not too small. Can you see at the back? Or is it too small? That's okay? Okay. So WebAssembly Studio is interesting. It's basically something that's you can code in C inside of your browser and basically build and run. So it creates it compiles it sends your code to their server, builds that on the server, and then comes back with a module that you can execute. So when you build that, then run, here you're going to be seeing that content here that shows 42. So what I can do now is add some more code. So for instance, I'm going to be adding a method that's called add, and I'm just going to be returning a plus b. Very simple one. Oh, I didn't say. So if I look at I can take a look at the output of that. So what's the output of this? It's basically something that's illegible, but the part that is interesting is the fact that there's a main method that returns 42. So it's basically returning the value that I had before in my program. So if I take a look at my C method, it just returns 42. Okay. So now what I can do is replace that 42 with something else and calling my method. Let's say I do 1 and 2. Save. Building again, running, and then I have my result, 3. So now if I go back to the WebAssembly module and I open that, then I can see that my method changed and that my return value is now 3, but I don't see my method add. And there's a good reason for that. It's because all those compilation tool chains that exist, and it's probably an LLVM that's behind it. So an LLVM is the compilation technology that allows to take C and emits proper machine code at the back. And there's a constellation of optimizers that allow you to do what they call constant folding and things like that. And take, if you're calling a method using constants, then you can just invoke that method at compile time and just produce the result right away. There's no need to let the CPU run that every time because you know the result ahead of time. And those optimization, they've been implemented already and they're used in WebAssembly. So that's very important. That's why most of the tool chains that do exist, like Rust, C, C++, all the optimizations that have been invented for the past 30 years, they're all there. There's nothing to reinvent. So now if I want to have that add method, I can do something a bit different. I can take what is called a WASM export. So it's basically metadata on the method that says that method, I want to be able to call it from JavaScript. So I just take that, put that in front of my method, just build again. The result is going to be the exact same, but at this point, my add method appears. And what that means is that method is exposed to JavaScript, and if as a JavaScript developer I want to call that method, I can. There's still the constant folding here, even though the method's there anyways, because the optimization has been made at that point. Any question? You all want to be doing this, right?
I have one question. So,
sure.
When you write .NET, you file assembly. That's kind of your unit. So,
yes.
And then you could import that in a .NET program. So in WASM, I mean, is there kind of like some sort of module idea so I can, write whatever module, write this module in whatever language I want, and then somebody else can pick that up and import it? I mean, is there like kind of a
yes.
easy, simple?
Yes. So at this point, no. But there's a new specification that's coming out of the W3C that's called interface types. And the basic idea behind this is it's just a spec that it allows for languages to expose a common interface. So let's say I'm a Rust module and I want to expose a string or a method that returns a string. Then I can specify that I have a set of methods or a specific method that takes an input as an integer and returns a string. And that module, that specification that says I can return a string can be reused by other modules from other languages that will be able to import that method that takes a string, but they will know how to marshal that string from a Rust string to a C string or a .NET string or a Go string or whatever. So that's the kind of thing that will happen. So that's what I call interface types, and that will enable some kind of a universal interrupt mechanism in a way that is similar to what a DLL export and import is done, if you know about that one. So for Win32, too, but for Wasm modules. So that will allow for an application that basically be developed in C# and import a Rust module without knowing about it. That's going to be the future. So we're talking during the next year. That's something that's going to happen. So at this point, doing that is fairly complex and has to go through JavaScript, which sucks. And you have to do lots of boilerplate code to do string marshalling and tag management and things like that. But that's going to disappear completely when next year happens with interface types.
Well, like with Blazor now, Blazor take the .NET framework and compile it to WebAssembly. So when you write a Blazor app, your app gets compiled and the .NET framework, which is
so that's almost true, and I'm gonna tell you why. So they're not compiling it to WebAssembly, and that's a very, very specific detail, and I've been working on modifying Mono to be able to do things like the other parts of .NET, and I'm going to be showing you that right now. It's going to be actually easier. Or maybe afterward. I'm going to be showing you that afterward and answer that specific question about taking .NET code down to WebAssembly. And they're not exactly doing that, and for good reasons. So in terms of WebAssembly in general, the timeline was interesting. It was announced in June 2015, and then if you take a look at the different steps, it's just 3 years. It's very, very small. And then Mono started working on it in 2018. And then afterwards, AOT support was added. So the reason for AOT, and that's the reason I'm mentioning about Blazor, is that Blazor is doing what Uno was doing at the same time. It's called the interpreter. So there's no compilation from .NET to WebAssembly. They're basically taking the IL and running an interpreter. So they're taking the IL and just running it one by one. So it's not actual WebAssembly code that's executed. So the runtime is WebAssembly, but the .NET code is not.
Okay.
So and as a key difference, because the runtime performance is pretty bad because of that. So and that's why AOT was introduced, and AOT is taking .NET and is actually producing, for every line that you write in C#, there's a corresponding WebAssembly line that's associated to it. And we're talking, around 30 times performance improvement in between the two. So that's a very significant one.
What is AOT?
AOT, sorry, I didn't mention that. So AOT is ahead of time compilation. So ahead of time means that it's about taking the IL and translating it to what the platform provides. So for instance, if you're on Windows and running on an x86 machine, AOT is going to be compiling that down to actual assembler for x86. Same thing for ARM devices and all of that. So there's the difference between JITting and AOT. JITting is at runtime, and AOT is at compile time. And so there's one for WebAssembly. And at this point, there's only Uno that uses AOT. Blazor is not using it because of time constraints. The completion time is very long, and the binary is getting bigger, and that's a problem for websites to have big payloads. So they added also a few other things like mixed mode. It's all about having half interpreter and half AOT compiled. That's something that Blazor will be using when it's released in 2020 at build,
Right.
and we're going to be using it as well. Well, we already have mixed mode, but we're going to be using a feature that they're going to be introducing in the future that's already available on Android at this point. So it's interesting because they're developing things for iOS and Android, and then it goes back to WebAssembly, and then WebAssembly does thing and it goes back to iOS and Android. So it's kind of a mix and match of features between all those platforms. For .NET and C# support, it's pretty similar to what I've shown a bit before. So it's C#, then .NET intermediate language, then the Mono runtime, then WebAssembly, and then you get mscripten, which is a library that emulates a few things for Unix programs. So the Mono runtime is a Unix program, so it gets emulated in some ways, but it's a nitty-gritty details that you don't need to know about. And then there's a bit of JavaScript, and then there's CPU underneath. So one thing I can talk about as well is the Uno Bootstrapper. The Bootstrapper is about getting a very small piece of .NET code to run inside of the browser. So it's not about running a full-fledged Blazor app or Uno app. It's just I need my just single line program to run there. So I'm gonna be just doing that one. So let's do just that. So it's about creating, taking just a .NET standard library and running that in the browser. So I'm going to be taking that .NET standard library here, and I'm going to be adding a NuGet package to it. There we go. So doing this, so adding the Uno Bootstrapper. Uno.Wasm.Bootstrapper, which is here, which is V1 since a few days ago. It used to be experimental and not anymore. My project needs to be an executable, so I'm going to be changing that here. So it's kind of a console application because it's going to be writing to the output of the browser. And I'm going to be just adding a console.writeLine here, and I say hello Orlando, and that's it. So it's not happy because I don't know, probably just to restore. Let's do all that. Oh, needs a method. So do you know about that? So if you're using that one, you may need something that's interesting. That snippet SVM is static void main. It creates that one. So let's build that again. So the library builds. Now it's generating a website, and I'm going to be showing you the details of that loading up. So now it's not. Now what I can do is just launch that, and it will go nowhere because I need to change something. Okay, so it starts in my browser, and once it's loaded up, it doesn't do anything. That's probably, let's see. Sometimes it does that again. So installing Visual Studio Update sometimes mess that up, so it's all about testing that the right way. Let's see, maybe I'm missing that as well. Let's try again. Okay, I'm going to be showing you what I mean by that. So I tried to do by heart, but I missed it. So there's a repository that's open source, and there's all the directions to do that there with a project that's already set up. So it's basically all the instructions to do that by yourself if you want to. If you're using a Uno project, you don't need to do that. It's just done by the templates. But there's that I miss. So I'm just adding that properly. Let's do it again. Okay. Let's see this time. Will it be better? It should be. There. Okay. And it shows nothing. And why does it show nothing? It's because we just did a write line. And where does the write line go? It goes to the console. Hello, Orlando. Okay. So that's what it does. So if we take a look at what happens really in the background, if we reload the site, we'll see that basically there's a, so if I skip the breakpoint, on the network, you'll see that there are quite a few files that are downloaded. So there's a few JavaScript files, and there's a Mono.Wasm file that's downloaded. Oh, don't pick it. There's a Mono.Wasm file that's downloaded, and that one has not changed because it's the second time. But it's basically that, and we'll see a few other things like, I'm sorry, it's a bit small. We'll see here that there's .clr files and system files and class library. So it's basically the 3 files that are needed to execute the console.write line. And that's pretty much it. So, and the reason you may ask what are those CLR files, is basically to work around all those nasty antiviruses in corporate environments that don't like DLL files. So that's the reason why there's a CLR file. There's no CLR extension. So it's already configured if you're using the Uno templates. It's already configured to serve the proper MIME types, but that gives you an idea of what that is. So there it is. So that's
these files are really only a few bytes, really.
yeah. It's not big. It's well, those are not the right ones. So let's see if I just refresh completely, because there's the cache that's kicking in. So the actual size for that is going to be, so the runtime is the biggest one. So we're talking a GC and all of those things with an interpreter.
That's the entire Mono runtime.
It's the entire Mono runtime. The BCL is stripped down. So there's the linker that runs. So everything that's not used. Everything that's not used is removed. Sorry about that. So everything that's not used is removed.
You'll make it
That happens.
glass of water?
Oh, it's gonna go away. And it's removed completely. So when it's not used, it's removed. And so that means that the application is going to be varying in size depending on what you're going to be using. So if you're using, let's say, JSON.NET, JSON.NET is pulling a lot of stuff. So your application may triple in size because of that. So just so you know, it really depends on what you're doing. It's exactly the same thing that is happening on iOS and Android. The linker runs and it removes the code that you don't use. But if you're using a lot of things, then your application gets bigger, which is quite different from what you'll see with NEM or normal, let's say, ASP.NET websites, because those websites, you don't need to link anything. You just put that on the server and that's it. You don't need to do that. But on the client side, you may want to have the smallest payload as possible. So you need to remove the code that you don't use.
This is true cross-platform.
This is actually true cross-platform, yes. So that's a bootstrapper. So what about the UI? So how, when I just do have a write line, how can I show something? And that's where interop and calling JavaScript gets interesting. So we're going to be just doing that and just pushing the idea. So just to give you an idea of what other frameworks are doing. There's multiple types of rendering when we're talking about the web. The first one is basically rendering HTML directly. So in terms of Blazor, you have your HTML inside of your Razor pages content, and it just renders to HTML directly. So there's not much of a translation. It's just expanding HTML to HTML in a way. There's also canvas rendering. That's what the Windows 2000 virtual machine is doing. It's basically taking the pixel, the frame buffer that the video driver for Windows 2000 is drawing, and then pushing that to the canvas. So that's another method. That one is basically rendering by the pixel. So that means that it may look odd. It does look odd because it's not exactly the same. It looks odd because it's maybe not be familiar. This is the Qt rendering, and it looks like what a Linux app from the early 2000s may look like. So you can change the design, but that's what it looks like. So it's not what the browser provides by default. And that's the notion of HTML rendering, and that's what Uno uses. So basically you have another markup language, and that markup language is expanded to something else. So on this end, if we take a look at that, I have a stack panel here that's translated over to a div that has a type, an absolute position, it has width and height, it has a few other things that allows it to render properly inside of the browser. So we're talking about CSS to do coloring and to do shaping and things like that. SVG to render paths and other complex shapes and things like that. So we're talking here also about pointer events. So everything is rendered directly into the HTML elements. That's also what OE is doing. I don't know if you've heard about that one. It's a framework that allows to do Xamarin Forms on WebAssembly. And it's something that Uno kind of replaced in a way. I'm going to be talking about that at some point during this presentation. I'm going to be taking, so another interesting one is the Uno Playground. So the Uno Playground is about testing your XAML without having to install anything. You don't need to have Visual Studio running or anything. So I'm going to be showing you that one very quickly. The Playground is just an application that shows you a few things like a list of samples, like if I want to test borders, I'm just loading up borders here, and it's going to be showing me what borders can do. I can change that up with, let's say, if the colors are not the right one for me, I can change the border thickness to, let's say, 30, for instance. It's just going to load it up and change the border. So it allows you to test without installing anything how your XAML is going to behave right away. It also does things like JavaScript, JSON parsing. So we're talking about JSON.NET that parses that content, data binds it to the combo box that's defined here. So for instance, if I have the selected font here, if I change the font here into something else, then it's reformatted, but it says that the selected font is now Comic Sans instead of, or Arial or whatever. So it goes both ways. So the data context that changed because it's data bound here just moves over back to the JSON that's at the bottom. And it's actually JSON.NET, the unmodified version of JSON.NET that runs inside the browser. And that's the coolest part. We can take a lot of things there and make them run inside the browser without changing anything.
It's any .NET standard library.
Yes,
Okay.
and that one is interesting. That sample is to show you how far you can go into integrating .NET code. This application is, I call that a tech soup because it has so many things that the sample itself is not very useful in terms of doing things. But maybe some people may find something interesting in there. So that side is C#. So it's a text box that contains C#. When I press the execute button, it's going to be compiling that using Roslyn inside of the browser. So this the entire C# compiler that's hosted inside of the browser. It's generating an in-memory assembly. It's loaded inside of the runtime that is inside of the browser. So nothing's gotten outside of the browser at this point. And then it's using Entity Framework Core that's inside the browser itself to communicate with a SQLite wrapper that uses SQLite underneath. So there's a SQLite compiled, so the SQLite engine that's in C compiled to WebAssembly, and we're using that inside the browser to modify the content of an in-memory database that's stored inside of the SQLite DB of the browser. If I refresh, it's going to be there.
Is it using IndexedDB?
It's storing is using is that IndexedDB.
So
Yes.
there's a driver, well, not driver, but something that.
Well, the interesting part is that it's actually an actual file of SQLite that's stored as a blob inside of a single row of IndexedDB. So it's kind of weird in a way, and that's where the interface types is going to be very interesting with the WASI specification, where browsers are going to be able to implement things like file access and network access, and avoid that kind of funky behavior of storing a file inside of a file instead of a DB. It's kind of weird. So that's gonna improve in the.
It's an interesting thing, though.
It's very interesting.
Just put a SQL, the DB and index DB
Yeah.
to persist it.
Yes.
Across.
And it's actually a file system. So there's a mscripten, which is the thing that emulates the Unix file system. They have some things that is basically the whole node system, the Linux node system to storing files. And basically you can write a file and it's going to be persisted to IndexedDB. So there's a whole file system that's persisted into an IndexedDB. So that's an interesting one. And to show you that I'm not inventing that thing, I'm going to be changing that code that's there. So I'm adding a line and then reading that line again. So I'm going to be changing that to something else, or well, let's say Orlando.msd_conf if that exists. So I'm executing that again, parsing again that module, that C# file, adding that line, and it says Orlando.msd_conf. So it's modified the database that's in memory through Entity Framework using code that's compiled inside the browser using the full C# compiler. That's a lot.
Nothing left the browser.
Nothing left the browser. It's all there on my machine inside the browser. So that gives you an idea of the things that you can do. It's clear the matrix. that shows that you can basically take very, very, very complex pieces of code, a full compiler is quite complex, and run it inside the browser. So let's go back to the slides. Another one that's interesting, Skia Sharp. Do you know? Do any of you know about Skia? A little bit. Oh, so Skia is what Chrome uses to render itself. So it's the library that allows Chrome to render its content, pages, and all of that. And we've been able to take that one and basically have. So there's an implementation of Skia that's called Skia Sharp. It's basically a binding that allows to call the methods from Skia and do rendering. So it allows to do things like blurring and things like that. So you can do. So it's actually rendered at runtime. So if I'm doing that kind of things, it just re-renders every single time. So it's blurring an image through WebAssembly. So this is completely local, and it's a gigantic piece of C++ code that does that kind of thing. That's built to WebAssembly and used from C#. So same thing, you can do lots of very interesting things there through filtering. Hot reload, you've seen a few things that I didn't show. We can hot reload parts of the XAML. So if you're having a control that contains a control that contains a control, then you modify that file, that one, and visually it's in between, then it's not the whole page that's going to be reloaded. It's just the control in the middle. So if you have state that stays outside, it's going to stay active. It's not going to go away. There's a few other things like gitpod, but I don't think I'm going to be showing that. Depends on the time. Maybe after. Another thing that's interesting is the WebAssembly renderers. So some people here have been using Xamarin Forms a bit. Okay. So just to tell what Xamarin Forms is. Xamarin Forms is it looks like Uno in terms of getting access to Android and iOS. It uses a different XAML, and it allows to go to iOS and Android and using a system of renderers. So it takes a control like a button and renders it to the platform using what they provide, which is renderers for iOS, Android, and UWP. So that application that's been developed using the XAML from Xamarin Forms, it can run on Windows as well. But the interesting part is that UWP set of controls that they built, because it's built on top of UWP, it can run on top of Uno. And because Uno can run on top of WebAssembly, then a Xamarin Forms app can run on top of WebAssembly. So that gets into very interesting scenarios where people have been developing applications using Xamarin Forms for a while, and they can now take their own applications and put them over to the web, where they could not be doing that before because it was not supported, and only UWP and iOS and Android were supported. And interesting thing was when we announced that, someone from the Xamarin Forms team that was making a pool management system with chlorine levels and things like that took that code added the feature to enable the WebAssembly support for its application and just pushed it over to the web, and it worked. So that's a very interesting story about that one, about using Xamarin Forms. So I don't know if maybe I can show you that one. Let's see. Let's try that. So let's make a Xamarin Forms application. And it's going to be a master detail application here. So I'm using the out-of-the-box templates that Microsoft is providing to make the Xamarin Forms application. So it's pretty much, it looks like an application that comes from, pretty much looking like an application that is from Uno, except that in that context, the XAML is contained inside of a project that is a .NET Standard 2 project, and that is what Xamarin Forms references. So what I'm going to be doing is basically building the UWP application just once so that you see the content, and after that I'm going to be using a .NET new command that is going to be adding the WebAssembly head to that project. So that's interesting. That's the template from Visual Studio, so it's probably broken somehow. Let's see. That looks better. It looks better. Okay. So when I launch that application, I basically have an application that's been developed using the Xamarin Forms views and about page and menu page and things like that. So it's an application that basically shows how to do a master detail page, selecting a few things on the side, and having items. When you click an item, then you can view its content, and you can see here that you can add a new item and add a few items there. So that's basically what that Xamarin Forms app is doing. So what I'm going to be doing now is I'm going to be going to the command line and adding the WebAssembly targets. So if I go to the demo, it's the app4. Okay. And if I go to the command line, so it's going to be command line, Visual Studio. So there's .NET New. So if you tap .NET New, it's going to tell you, it's going to give you a list of all the templates that are available. And there's one for us that is called the Uno Platform WebAssembly Head for Xamarin Forms. It's a mouthful, but it's what it is. So it's basically type .NET New and then the name of the template. It creates the project for you. That's what Blazor uses for creating projects if you're using command line or Visual Studio Code. So I'm going to be going to.
There used to be a thing in Explorer, you could right click and say run command line here. God, that was the best thing.
Yes, it's still there, but in that context, you don't have access to .NET New if you're doing that. So you have to go through command and all that. It's it's a bit different. So .NET New, WASM head. Oop, just a bit too much. .NET New. Okay, so I forgot to check one thing. So I'm going to be adding that manually for now. So they add a feature when if you're in a specific folder, the SLN is placed above, and it makes it complicated to add. So I'm going to be adding the WASM file by hand for now. So that's my WebAssembly file, the WebAssembly project. It's basically the same thing that we've seen before when creating a template using Uno. It's just that it doesn't contain anything aside from a few styles, or maybe in that context it doesn't have anything, just bootstrapping and the assets. And when you run the application, it's going to be doing the same thing that you had for a normal application, but running a Uno application, but running a WebAssembly application, a Xamarin Forms application instead. So it's compiling. So that part that takes a bit of time is the linker. So it has to analyze everything that the application uses, and determine what's used, what's not used. That piece of code is not multi-threaded, so it runs single CPU. So if your code can be is large, then it can take a bit of time to run. So sometimes you can disable it, but if you do that, then it's going to cause you a lot of problem afterwards. So you better have it running when you're developing your application. So that is going to be the same application that's running inside the browser, and you can see that it's the same items, same menu that has that content, and basically it's the same thing. So the add button is not there. I would need to update the NuGet package there, but we've fixed a lot of things for the support for for WebAssembly, and just updating the package and fixes everything. So that's it for WebAssembly support for Xamarin Forms. So if you have an application that uses Xamarin Forms and you want to run to the web, that's a way to do it. We announced at UnoConf, our annual conference, that is only the first iteration that year. So if you want to come, it's in 2020 September next year. We announced cross-platform UI testing that includes WebAssembly support as well. So basically, you can test you can have the same behavior on all platforms at once. So we're talking about clicking on, tapping on an element, waiting for an element, taking a screenshot, reading the value of a dependency property of an object that's inside of the application, asserting its value, and that kind of behavior. So that is something that was very important for us, for Uno itself, to be able to validate that behavior. And what's interesting at this point, when we were building Uno for itself, we have a sample application that basically tests all the behavior of the application on Android, iOS, and the web inside of every PR. So if you're making a contribution, then your code is going to be tested and UI tested on all those platforms for every PR that is made inside of the Uno repo. And you could be doing the same thing for your own project. So if you're making a project that does have some UI, you can have the same kind of validation. So the web is using Selenium in the background, in the back, and it's surfaced through the same APIs that Xamarin UI Test is using. So if you've been using that to test your applications on Microsoft App Center, that's what they're suggesting to use to test iOS and Android applications. So WebAssembly future. There's quite a few things that need to be fixed. Accessing browser features takes some time. You have to go through through JavaScript to do things, and it's problematic. It's still slow in some cases, and there's a few things like type system is not the same, so it's quite difficult to manage properly. So that's what host binding is going to be. So the new name is interface types. Garbage collection is linked to this. So if you get a DOM node from WebAssembly, you have to have a handle to it, and you have to be able to manage the life cycle of that handle. So you don't want the JavaScript runtime to just take that reference away and you cannot use it and call methods on it. So that's something that's coming. Exception handling is another one. At this point, exception handling has to go through JavaScript to be managed properly. So if you're doing something like try finally in C#, the content of that method needs to go through JavaScript first and then come back to WebAssembly to be processed properly. And calling, the performance impact of calling JavaScript and coming back is about 6 times slower than calling a WebAssembly to WebAssembly directly. So it's significant. And also threading. Threading is done through, at this point in JavaScript, it's done through web workers, and that's something that needs to be adjusted. So current browsers have added support for it, and it's going to be enabled into all the languages that are coming, as well as in .NET. The Mono runtime is adding support for it, and that's going to be very interesting to see what's going to happen with that is enabled for .NET programs. So that's pretty much it. Before that, I want to show you something that I missed. So Microsoft has been publishing an application that looks like this one. It's the calculator from the Windows calculator. They open sourced it I think before, but during this year, earlier this year. And basically, it's a C++ application that we've basically ported over to C#, and then ported over to your devices like this. So on an iOS device, you basically get the Windows calculator running on your iOS device with the same feature set. And that application is also running inside of the browser. So it's the same application running inside of the browser. And you don't need to install anything, it just happens to be in your browser. So that's the coolest part. So that application is interesting because it's using a few features like what we call DLL import. So if you've been there for a while using .NET, DLL import is about calling native methods. And in that specific scenario, the calculator is using a very old calculation engine that dates back from 1993, and we didn't want to change that, so we left it at C++ and combined it to Wasm directly, and then we're interoperating with it through pinvoke. So we're calling the methods that are exposed from that calculation engine from C# so that the calculator can work properly. So when I'm doing that, all the operations that are made, and that number actually comes from that code that is written in C++ that dates back from 1993. So
is it old? Is it like an old math routine?
They call that an infinite precision calculation engine. So it's doing very funky things in C and doing pointer manipulation that you don't want to manage by yourself. So that's why we left it where it belongs in C and C++. It got compiled into Wasm directly, so it's a small module, and that module is loaded up from C# using pinvoke, platform invoke, so that we get all that behavior for free in a sense. So yeah, everything there is in C#, and it's all open source, so you can go poke it and see how it goes. When we were talking before about visual states and the fact that an application should be responsive, the same behavior about removing some content and disappearing columns is there as well. See, so yeah, this application is something that is common to people. It's simple to understand. It's localized in 62 languages. It's accessibility enabled. So if you're blind, you can use it using VoiceOver. So it works on iOS and device. Not yet on the web, but it will be soon. So if you have an iOS or Android device, you can use VoiceOver to use that application. That's pretty cool. That it's something that we just ported over from the actual source code that comes from Microsoft, and it just worked. So that's pretty cool. So
yeah, I think Wasm's going to kill a lot of stuff.
It will.
Eventually.
I mean, JavaScript was basically there for, I think it gained its popularity because it's been there for a while, and it was the only choice. And because of the fact that browsers are available everywhere, it got popular because when the only thing you have is a hammer, everything looks like a nail. So you have JavaScript. Well, it's gonna hit with with JavaScript. So it will probably change a little bit, and out of constraints, good thing happens. There's lots of good things that have happened because JavaScript was constrained and the environment was constrained. React, for instance, is a good thing. The new paradigms have been invented or pushed into production, so that's a good thing. But it's not a good thing to just throw out all the development that have been made for the past 40 years. I mean, Fortran could run in that environment, and people that have written that Fortran are probably either dead or don't want to program anymore. So let's take that code and put it over, and it's still going to work. It's not legacy; it's just old. That's it. So it's going to be very interesting to see what's happening in the next few years with this.
Have run COBOL.
Yes, why not? Why not?
No, the thing is, why would you run COBOL? There's a lot of code out there.
Yeah, exactly. Any other question?
Good stuff.
Yes.
So, I have an old web application which we're trying to migrate over to the newer technologies, but we have an application database sitting on a server, and we need to communicate back to that. So how do we do that through WebAssembly?
So,
I can
yes.
imagine taking the business rules, compiling those to WebAssembly and hosting them in the browser, but still we need to get information back and forth.
So the best way to think about that one is to think like a mobile application or a fat client in a way. You don't want to dialogue to communicate with your database directly. You want to have some kind of a web API somewhere that you can communicate to that has all sorts of rules and management and security features and things like that. Because you may want to expose that to the web, probably. I don't know if it's an internet application or if it's open to the public.
Yeah.
But depending on that, think of an application like that needs to communicate. And there's basically two ways to get out of a web application like that. It's either you use HTTP client. If I translate that over to what .NET does, so it's the fetch API when you're in JavaScript, or WebSockets. That's the only.
Or gRPC.
Yeah, but it's going to be using it's going to be using HTTP underneath.
Right.
It's going to be fetch
Right.
in any case. So it's going to be HTTP2 or things like that. It's going to be multiplexed or anything. But it's the only two ways you have to get out of a web application. The only thing that differs between those two is the fact that WebSockets don't have CORS limitation, and those ones are pretty complex to work around when you're doing fetch. Especially if you're in a let's say intranet environment and you want to be able to go out of the origin website that you were into.
Yeah.
So that may be a solution to let's say access a faster middle tier in a way to get to a database somehow.
Right, okay. So if I was to replace some of that, we're not going to do it all at one time. We're going to have to do it bit by bit. So I could theoretically host some WebAssembly in a frame somewhere and then switch back and forth.
Yes, so theoretically. So and you're a second person today asking me about the exact question. Yeah, there was someone at Ignite that was having the same scenario. So WebAssembly is made for that. It's about creating a module and calling functions into that module and doing interesting thing with it. The problem at this point is that Mono was not built for that. They chose to make it some kind of I'm the master of a page. So if you're instantiating a WebAssembly application, then it takes over the rest. So technically it's possible. It's just not possible yet. But yes, at some point it's going to be. So.
But you could host it in an iframe, so it would have.
Yes, that you can do. That you can do. But if you do that, then you're going to have all the message passing and security features that are going to be bugging you and all that. But you could be hosting that as a kind of if you were integrating in an NPM module in the same way. It's and for that matter, most a lot of WebAssembly modules are actually NPM modules and they're distributed that way. So it would be the same thing for a .NET module. It will technically be possible to do it, but it's just not possible yet.
Okay.
Can I ask a quick compare and contrast? Blazor on Electron,
Yes.
or Uno, it seems like they're both doing C# and WASM.
Yes.
Is XAML? I mean, it seems like the hot reloading is very nice. I don't know if Blazor is some other thing, but what am I getting with Uno over Blazor?
Okay, so there are two things. So on the Blazor side, the support for Electron is actually structured in a way that the .NET code runs inside of .NET Core. So it's running on the host system directly. So it's running. There's nothing different. There's no WebAssembly in that sense. And they're using JavaScript interop and name pipes and all of that to communicate to execute JavaScript and modify the DOM that way. The reason it works in that model is that they don't need to do asynchronous. They don't need to do synchronous calls between the .NET code and the JavaScript code that modifies the UI, and that's why the server mode of Blazor works. So they can have asynchronous calls, and that's not going to be a problem. It could be a problem for other cases, and it actually causes trouble with the latency that it introduces because it's async. It's async, so there's a few things that to deal there, but that's where it works. So in terms of Uno running on Electron, what we're envisioning, and that's why Microsoft has been had approached us at the beginning, is that it's possible to run that code inside of WebAssembly inside of Electron. So it's possible to do that. It's just that the .NET code is running in WebAssembly, and that's the key difference between what Blazor is doing running in .NET Core, let's say outside of Electron in a way.
But we're actually looking at it the other way
Yes.
around, right? So you're asking about Blazor being a web technology first and foremost to run in the context of a shell, so it can run on desktop and access the desktop feature. We're looking at it of bringing WinUI from the desktop, because it's desktop technology, all the way to mobile natively by tapping into Xamarin Classic, and bringing it to the web by tapping into WebAssembly. So if you look at it this way, why would you run Electron on desktop if you have that same 100% code base running natively on desktop through WinUI and running natively on mobile through Xamarin and also on the web, right? So there's no point of trying to wrap your web back into a shell to run desktop. You have that same code base running natively on desktop. So that's the idea of why we went down that route. So purely possible. So for example, where it becomes valuable because we don't have a backend today for macOS and Linux, then it makes sense to take our WebAssembly code, because we don't yet have a macOS and Linux, and then wrap it into Electron to target macOS and Linux for those users that care about it. But for the Windows desktop, it doesn't make sense. For mobile, it doesn't make sense because we'd rather have the native ones. Unless you want to have the ease of deployment or just having the WebAssembly like web-facing lane that it then can be wrapped into a progressive web app, for example, where it then downloads and installs a shell and all that. But like the idea of starting from a web technology and bringing it to the desktop, like we have the desktop app already available on Windows.
So hypothetically, you're looking at much better performance.
Yes.
Yes, of course. The only part where Electron gets some interest in terms of getting to macOS or Linux is that you get access to the platform features directly. Because on the web you're in the sandbox of the browser, so you don't get access to, let's say, writing to the file system, for instance.
And I'd be careful with Electron nowadays. Like if you've seen like 48 hours ago, Apple banned Electron apps from the App Store, from the Apple Store. So like it's getting tricky every single day.
Didn't Sanderson do something recently where he ran
Yes.
the Blazor outside of Electron
Yes.
natively?
Yes, he used that. He used actually a web view and just invoked into the web view to do that. So yeah, it's something that we can't do yet, and we're working with Microsoft to enable that scenario as well.
Cool.
Was that useful? I'm sorry. Another question.
I was just wondering, like, so I was actually using for like the past week another cross-platforming library called CTO Forms. Do you know anything about that one as well, or because I use that to actually to port Windows applications to Mac, and like you said, Uno can't do that yet.
So there are many open source alternatives that allow to be running that one. I'm not familiar enough with that one to give you a definitive answer. But it all depends on where you're coming from, and people have been asking Microsoft. So we have Blazor, you have Xamarin Forms, you now have the ability to do some Uno at some point. Then there's React Native, and there's WPF, and there's WinForms, and all. The point is not the number of technologies. It's all about where you're coming from and the investment that you've made inside of in a specific technology. Yeah. And if you're a React developer, fine, you can use React Native and just go over to Windows using that. If you're a web dev, well, just use Blazor because it makes more sense for you because you know HTML, you know CSS and all that. If you're a WPF developer, well, Uno may be more interesting for you because you know XAML, you know bindings, you know all of that because it's just more familiar, and you can reuse all that C# code that just data binds to your view and all that. So it's all about where you're coming from and where you want to go to.
But I'll give you my answer because I know a bit of ETL and it's the same thing like with Avalonia and all the other technologies. Right? And like I'm looking at it from a service agency provider. Like we're getting paid to build apps, and the primary reason why we built Uno in the first place is to make sure that we be aligned with A, Microsoft, and B, Microsoft's ecosystem. So when you're looking at those technologies, why we took the approach of going with WinUI, used to be UDP, first and foremost, is we want to make sure we'll be able to reuse and tap into the developers' ecosystem. So Jerome was talking about Windows Community Toolkit and the XAML behaviors and all the MVVM frameworks out there. So we don't want to have to create a new ecosystem, which Flutter is doing right now, which React has been doing in the past as well. Like, I don't want to have to try to bootstrap a new ecosystem where developers will have to target Uno as a target platform. No, I want them to continue to build for WinUI. And the only promise we're going to make is if you build something for WinUI, it's going to work everywhere, which isn't the case when you're starting from scratch. Like
Just one code base. I think that's the biggest.
Yes.
One code base.
One code base. Don't reinvent. Don't bootstrap again the ecosystem because it costs so much.
But also, like people are asking, where's Uno's documentation? How can I code Uno? You don't actually code. In theory, you're not coding. We're just like the magical glue in there that ports everything. Like we're a bridge to the other
just
platform.
effing magic.
Just build a WinUI app.
Your
and it's gonna work
JFM,
everywhere.
just
That's-
effing magic.
I think we're gonna move the conversation
Yeah,
to.
yeah, sorry.
We're actually a little.
We have-
Yeah, we're over there.